Okay, so this is a second example. What you should notice in this example is you're given the supply voltage, you're given the supply current, you're not given a value of R1, but you are given a value of R2 and R3. So this would have the same type of equivalent circuit, albeit that you don't know the value for R1. You could get a value for RP though. So using the same technique that we used in the last circuit, we're going to work out the value of RP. That's our first rule. So we know that 1 over RP, 1 over R2, plus 1 over R3. And using our calculator the same way as we did the last time. So 10, 1 over, plus 40, 1 over equals, and our final 1 over. So that gets us a value for 8 ohms. So 8 ohms. So that 8 ohms is the value in here. This would still be 20 volts. This would still be 2 amps. So we spoke about before, if you know your Ohm's law triangle, I'll pop it in the middle again here. VI and R, you can do it for the whole circuit or you can do it for one component. So I'm going to use that on the whole circuit now. So I know my voltage, I know my current, so I'm going to get my RT. So for my full circuit, R total, I'm going to use my total voltage, my total current. So my total voltage in the circuit is 20. Total current in the circuit is 2. 20 divided by 2. If you need your calculator, use your calculator. That gets you 10 ohms. So 10 ohms. So I know I've got 8 ohms here, and I've got 10 ohms in total. So R1 must be 2. So that's going on the basis that in a series circuit, R total would be R1 plus RP. You know your R total is going to be 10, that's from there, equals R1 plus the 8 from there from RP. So R1 must be 2 ohms. That gets you the value in there. Again, we could work out the voltage across R1, call that V1. The voltage across RP, call that VP. They would translate to these voltages as well. They would be the same values. And then using these values again, you could work out the current through this resistor here and the current through this resistor here. So we'll do that just for the sake of completeness. So V1, I times R1, just the same way as we did before. So 2 times 2 gets you 4 volts. 4 volts here, so you'd expect this to be 16 to make up the 20. V2, I times R2. 2 times 8 gets you 16 volts. These would be our voltages V1 and V2. The only other things we could work out would be our I1. Let's separate that off. So we're looking at one component again, using our triangle. V1, no, I1 here, VP over R2. I1 only exists going through R2. So VP, got that over here, which is really this one here, not I2, 416 divided by 10, 1.6 amps. So of that 2 amps, it comes up here, hits that junction and splits. 1.6 amps goes this way, so this must be 0.4 amps. Let's check that. I2, V parallel again over R3 this time, 16 divided by 40. 0.4 amps. That checks out. 2 amps comes along, splits here. 1.6 goes this way. 0.4 goes that way. 1.6 plus 0.4 gets you to this value here. So it'll rejoin at this point here. And then it's 2 amps that goes back to the supply. And that's that example complete.